Hi guys, Crafting Redstone here, and today what we're going to be doing is having a look at how we can combine logic gates, the basic ones, into more complex ones such as the Xor Gate. Now we're going to start off with these three basic logic gates, and I'm going to quickly show you what they are and how they work, and then we're going to move on to some of the more complex ones later on. But to get started, let's have a look at these three logic gates. To begin with, we have the OR gate, and this OR gate will only turn on if both of the inputs or either of the inputs are on. So as you can see, it turns on with one input and also turns on with the other input, and also will turn on with both the inputs on. So that is the output over there, and these are the inputs. And if you're wondering why these look a little bit different, I am using a texture pack, or a resource pack I guess they're called now, to change the colour of the lamps, the torches, the redstone and a few other things. So if you've noticed some difference from normal Minecraft, that's what it is. But this is vanilla Minecraft, so no mods or anything. And as I said, this is the OR gate, and this is very useful. This is one of the most basic logic gates you can use and combine into more complex ones. And next I'm going to show you this NOT gate. So now we're going to move on to the NOT gate. The NOT gate is probably the most basic logic gate you're going to come across. Now what it does is just invert the signal. You see, it literally just inverts it. Now this is very useful in combinations with other logic gates, such as the OR gate, and that will make the NOR gate, and the AND gate, which will make the NAND gate, and the Xor Gate will make the Xnor Gate. Now I have shown all of these in another video, so I'll leave a link to that in the top right hand corner of the screen now, and you can see basically all the different logic gates and how they all work. Without further ado, we're going to move on to this AND gate. So now we're going to take a look at the AND gate. Now the AND gate will let a signal through if both this one and this one are on. So as you see, currently nothing happens, but if we put both of them on, this and this one, then it will turn on, and if we have either of them off, then it's not going to produce an output. Now the AND gate is, as I said, one of the basic logic gates, what are very important in combination with the other logic gates to make more complex ones. Now we're going to move on to some of these more complex ones and take a look how we can make them, and how we combine these three very basic logic gates together to make more complex ones. So as I said, let's move on. So this mess of redstone is the Xor Gate. Now what the Xor Gate does is basically only let a signal through if either of the inputs are on, but not if both of the inputs are on. So I'll demonstrate that in a minute. But this is very useful, and you can use it in full adders, what I've done a video on, and I'll put a link to in top right hand corner of the screen now. And as I said, many other things as well. So how this works, I said, if both of the inputs are off, then nothing will happen. If one of them are on, like this, then the output will be on, and also if the other one is on, then the output will be on. But if both of them are on, then the output will be off, as you can see. So that's how that works, and I'm going to show you basically what's happening here. So here what you can see is a NAND gate, what I'll come to in a minute, and this basically works like the AND gate, but the opposite of an AND gate. That's what that is. This is an OR gate, like what I showed you earlier, and this is an AND gate. So let's just go through this. An NAND gate will let a signal through as long as both of them are not on, both the inputs are not on. So this basically means it will let a signal through on the 0, 0, 1, 0 and 0, 1 inputs. But on 1, 1 it will not let the signal through. So this deactivates the AND gate here. Now the AND gate will only turn on if both of these are on. So that is why that is there. And the OR gate will turn on if either of the inputs are on and if both of the inputs are on. So this basically, coupled with the AND gate and coupled with the NAND gate, will only let a signal through if either of the inputs are on, but not if both are on, and not if neither of them on. So that's the Xor Gate, and that's how you make it with a NAND gate and an OR gate going into an AND gate, which produces an output. And that is how you'd go about making the Xor Gate. Just to mention quickly, this jumble of redstone wires at the start is irrelevant and has nothing to do with the Xor Gate. The Xor Gate is literally just this bit here. But now what we're going to do, as I said in the last bit, we had a NAND gate there. Now a NAND gate is the opposite of a AND gate. So if we construct an AND gate like so, as you can see, the output is currently off. Now we will grab a lever as well. That is there. I'm going to place one on here and one on here. Now I'll also grab a repeater and a lamp to show you what's happening here. So currently, what is happening is there is no output because this is an AND gate and would need both of the inputs to be on before it would produce an output. But combining it with the NOT gate would get us a NAND gate. Now what this does is exactly the same, But here, instead of having that redstone torch at the front there, we just leave that out, put a repeater here, and put a lamp there. Now it's producing a NAND gate, and how this works is that if one of the inputs are on, then it will still stay on. If the other input is on, then it will be on. Alright, and if both of the inputs are on, it will turn off, like so. That is a NAND gate, and that is an AND gate coupled with a NOT gate. Now the other one is the NOR gate. Now the NOR gate is basically the same as the NAND gate, but with the OR gate. So that probably didn't make any sense, but it's basically an OR gate coupled with NOT gate. But we're going to demonstrate that here. So this is an OR gate as showed before, and it will turn on if either of the inputs are on, like so. But a NOR gate is the opposite of that. So if we do this, and then we can have an output coming from this, like here, but with a redstone torch instead. Now what this will do is be on when the output will be on when neither of the inputs are on. If you turn one on, it's going to turn off the output, like this. So that is a NOR gate. Now the other main logic gate, I guess, is the Xnor Gate, and that is just the opposite of the Xor Gate. So all you do is remove this torch here and place it like that. So you can see it's currently got 1, but if we turn one of them on, then it's going to turn off. If we turn the other one on, it's going to turn off, and then we're going to put both of them on and it will turn on again. So I'll show you that there. Now these are all the logic gates, and as you can see, we've combined these 3 basic logic gates to make all these. Now if you found this useful, it would be very greatly appreciated if you could leave a like. And as I said, I hope you have enjoyed it, and I guess I'll see you next time. Thank you for watching. Goodbye from Crafting Redstone.
You